You here on this lovely sunny day that's finally warming up. Um, excuse me. I am happy to also invite Peter Lehman, who is the founder director of the Schatz Energy Center and a I'll get this out right yet, and a professor emeritus of environmental resources engineering at Cal Poly Humboldt. Peter received a BS in chemistry from the Massachusetts Institute of Technology, MIT, and a PhD in physical chemistry from the University of Chicago. He then served as a National Institutes of Health postdoctoral fellow at the University of California, Berkeley, where he conducted research on the aerochemistry of photochemical air pollution. Before coming to Humboldt, he was a member of the faculties of Sacramento State University, California State University Northridge, and Deep Springs College. While at Humboldt, Peter has served as chair of the Environmental Resources Engineering Department, co-chair of the International Development Technology Master's Program, and the founding faculty advisor of the Campus Center for Appropriate Technology. And I'm actually, before I turn it over to let him introduce Jerome, I want to mention that he has asked you to please put your comments in chat, and I'll be monitoring those if you have questions. And you can also, of course, raise your hand, but if you put them in the chat, then I will introduce them to him. So, Peter, it's all yours, and we look forward to your talk.
Thank you, Jane. And I should share my screen. Okay, can everybody see that? Is that working?
Yes, it's working.
Great. Well, thanks, Jane. And hello, everyone. As Jane said, I and my colleague Jerome, who I'll introduce in a minute, would be happy to take your questions. Actually, we'd be happy if this were a discussion rather than me just talking at you for the time. So please let me know if you have questions. Probably if you have a question, other people do too. So my colleague Jerome Curiozzi is a transit planner at the Humboldt Transit Authority. And Jerome and I used to be colleagues at the Schatz Center. And then when this program that you're about to hear about started, Jerome switched jobs and now works at HTA. And I can say is kind of chin deep now in a lot of this work that we're trying to accomplish at the Humboldt Transit Authority. So hello, Jerome. And Jerome is more familiar with, obviously, with what's going on at HTA than I am. And so questions involving that organization and what they're doing, he's going to be a great help. All right. How do I get this to advance? There we go. So I'm going to talk about some of the history that the Schatz Center has had with hydrogen transportation. We started doing this work over 30 years ago. So we've been involved a long time. And frankly, it's been a really rewarding to have the work that we were doing, which was always somewhere else, come to our home here in Humboldt County. I'll talk about why we're even thinking about using hydrogen as a fuel for clean transport, and talk about green hydrogen, which is just beginning to happen now and is really the holy grail. If we use green hydrogen to fuel a zero-emission bus, then we have really produced a completely clean, completely renewable transport system, and that's where we want to go. We'll talk mainly about HTA's plans for a zero-emission bus fleet. And Jerome and I wrote a grant to this program, the Transit and Intercity Rail Capital Program. It's a California program to fund transit and rail in our state. We wrote a $39 million grant, and it was granted. It was approved. We are going to get 11 new fuel cell electric buses, and we'll talk about that. There's going to be a new route which has already begun between Eureka and Ukiah, which will link transit travelers eventually to the Bay Area. We are in the process now of, we have a request for proposals out to build a hydrogen fueling station, and we'll talk about that. And part of the grant is to develop a new transit center, the Earth Center in downtown Eureka. And then we'll talk a little about what's going on nationally and worldwide with hydrogen transportation. Any questions so far?
I have one. Why is hydrogen so efficient in the sense that it is the greenest of the green? Is that because it doesn't take much energy to produce the hydrogen fuel, or because it simply turns out water vapor?
Well, that's a complicated question. It's true. The only emission of a fuel cell electric bus is water vapor. Using renewable energy to power transport means you're either going to do it with a battery electric vehicle, like I drive a Nissan Leaf, like a Nissan Leaf or any of the other electric cars that are out there, or a battery electric bus where you charge the battery from the grid usually, and then drive the vehicle. And when it's discharged, you recharge it. So that's a battery electric. We'll talk about this a little further on, but there are reasons to not use battery electric buses for some of the routes that HTA has. And a fuel cell electric bus has advantages of doing that. And in order to run a fuel cell electric bus, you need hydrogen fuel. So that's a quick answer to your question. We'll get into more detail later as we get on in this presentation.
Thank you.
Sure. So we've been doing this a long time. As I said, we started, and this all started with a man named Louis Schatz, who was the person who financed our projects initially and left us an endowment when he died. And that is why we're here. He was interested in hydrogen energy, and he actually came looking for a research center that would research hydrogen as a fuel and as a storage medium for renewable energy. And he found me, I found him. We got along, and he financed the first project was the Schatz Solar Hydrogen Project that was at our Marine Lab in Trinidad. Some of you may have seen this. And the goal was to demonstrate that hydrogen could be used to store solar energy. And we had a solar grid. We had an electrolyzer, which produces hydrogen and oxygen from water. And we had a fuel cell which used the stored hydrogen to generate electricity. So instead of using a battery, we use stored hydrogen as the way to store energy. And that picture on the right is my colleague, Charles Chamberlain, who's been in this endeavor with me ever since the beginning, and me at the Schatz Solar Hydrogen Project. Then it was interesting. After we finished that project and did it successfully, which was a very difficult job, Mr. Schatz said, "That's great. What's next?" And what was next was using hydrogen as a transportation fuel. So we were doing this back in the mid-90s, and we got this project. This was our first big project at the Schatz Center. It was the Palm Desert Renewable Hydrogen Transportation Project. And as I said at the beginning, a lot of our work was somewhere else. And this was our first somewhere else. It was Southern California, the Coachella Valley of Southern California. And it was a huge effort, over $4 million funded by the DOE, the South Coast Air Quality Management District. They had a lot of money because the air quality in the South Coast is not the greatest, and the city of Palm Desert. And we built 3 fuel cell powered golf carts, a small car, which you'll see a picture of, and a fueling station in Southern California. And this was our prototype car. We drove it in the Palm Desert Electric Vehicle Parade. There's actually such a thing. The mayor is driving. Mr. Schatz was there, and a great time was had by all. And this was a very successful beginning to hydrogen transportation. And we, as I said, we built a hydrogen fueling station. It was the first one in the country. And that's the car that we retrofitted with fuel cell power. It was a Danish car, a Cavette. It was built to be a city car, drive around the city. Its maximum speed was about 35 miles an hour. It was battery powered. It had lead acid batteries. Remember those? And we retrofitted it with a fuel cell, and here it is being fueled up at our station. And the man on the right is Greg Chapman, and he is still my colleague. And he and I are working with the Humboldt Transit Authority to implement this new project. Any questions so far?
None in the chat. Feel free to
Okay.
put them in the chat, everybody.
So another step was we built a hydrogen filling station on what was then the HSU campus. And Greg was, you see him in the picture on the right, on the bottom. Greg was the project manager for this. He did a lot of the design and the implementation. This station was inaugurated in 2008. Mike Thompson was still our congressman then. Roland Richmond was still the president of the university. And it ran for 10 years. And it fueled a number of prototype fuel cell cars. Now, today you can go out and buy a fuel cell car. In those days, you couldn't. But these were 2 Toyota Highlanders that Toyota retrofit. They were prototypes. Toyota retrofitted them with a fuel cell power system. And we tested them for Toyota. And they worked great. We were among the first to be able to do these long distance road trips. There are 2 fueling protocols for fuel cell cars. The buses will be getting are so-called H35. That's 350 bar or 5,000 pounds per square inch. And cars are fueled at 700 bar, H70, 10,000 PSI, pretty high pressure. And we retrofitted our system, our station, to be able to fuel the 700 bar cars. And we were able to drive that car that you see down to the Bay Area where there was a station and fuel up and drive it back. And that was demonstrating that this kind of transportation was really going to work. And, that was a number of years ago.
What happened to the station? Is it still operating or what?
It is not. It is mothballed. You can still see the remains of the station there. I mean, here, let me go back. Oh, I can't go back. Why? Oh, there we go. Yeah, the canopies are still there. The tanks are still there. The dispenser is still there. The signage is still there. They look kind of old by now and rusty. But no, it has not been in use since 2018. That was the last that it ran. And now it's safely mothballed. You see that banner just above the car on the right? That was the Hydrogen Highway banner that was given to us. You remember the Hydrogen Highway? That was Schwarzenegger's idea. And someday, probably, it will come true.
Hey, Peter.
Is there some reason it was discontinued?
It just ran out of usefulness. It was still working, but the prototype vehicles were taken out of service. Toyota now has the Toyota Mirai, which is a fuel cell car that you can buy. It's a standard issue car now for them. And they didn't need anybody to test prototypes anymore. And, it was never, it was built, it was a small station, as stations go. It wasn't a retail station. It was experimental. And there was no purpose for it anymore. And it cost money to keep it running, and we mothballed it. So it had served its purpose, and the utility had kind of evaporated at that point.
Peter, this is Lou Litsky. I've got a question.
Yeah, go, Lou.
Yeah.
Good to see you.
Good to see you too. A number of years ago, Toyota announced that fuel cell cars were going to be their big alternative vehicle rather than electric, and they were going to be the pioneers that were going to set the world on fire with this thing. But it doesn't seem to have happened. I mean, EVs are the big thing right now. So my question is there something holding development of fuel cell vehicles back on a mass scale? Why hasn't Toyota really been successful yet in doing this? Or maybe I'm wrong, but what's your take on it?
Oh, you're not wrong, Lou. It's true that battery electric cars have taken off, and they have gotten much more, the range has increased, and the charging infrastructure is starting to be developed. It still needs to be much more developed for people to not have range anxiety. But I think, and we'll say this later, I think that this is me talking, so take it for what you will. I think that for light duty vehicles like passenger cars, that battery electric cars will probably predominate. I think Toyota probably miscalculated there. But for larger vehicles like buses and long-haul trucks, for example, I think fuel cells will predominate. So I think both technologies are important and will have a role to play. But I think less so with passenger cars. So I think you're right. You know, it hasn't taken off the way Toyota imagined it would. So why hydrogen? Why are we doing this? I think we've answered this to a certain extent already, but and as one of the listeners pointed out, when you use hydrogen in a fuel cell vehicle, it's clean, it's efficient, and it's quiet. The only exhaust is water vapor. And let me underline efficient. Fuel cell, you know, a typical internal combustion engine, even a good one, is around 20% efficient. That is in converting the energy in the gasoline into motive power down the road. And a fuel cell is significantly better. It's like 50, even as high as 55 or 60% efficient, depending on the circumstances, but it's clearly more efficient in turning the fuel into electricity, and then the an electric motor turning the electricity into motive power down the road. An electric motor is very efficient. They're like 95% efficient. So overall, a fuel cell electric vehicle is an efficient vehicle. Now, it costs you energy to make hydrogen in the first place, so there's that too, but we'll get to that later. We can make hydrogen from renewable energy, and as I said earlier, if you make hydrogen renewably, then you have a nearly carbon-free transport system, and that's what we're aiming for. Hydrogen is very flammable, as everyone knows, but it's odorless, it's non-toxic, and it's buoyant. So if there's a leak, it immediately goes up in the air and dissipates. Can it catch on fire? Absolutely, it can. It's very flammable and needs to be treated carefully. We used to, in the old days when we had students, young students show up at the Marine Lab, we would blow bubbles with hydrogen, and that was a big hit because the bubbles go very fast, go up in the air. Hydrogen is safe. You know, when we started this, there were no codes and standards for hydrogen. So when you saw that picture from 1995, nobody was using hydrogen as a vehicle fuel, and there were just no standards. Now there are. So there's National Fire Protection Association standard number 2, which covers hydrogen technologies. And there's a Society of Automotive Engineers, J2601, that covers a fueling protocol. So the industry has gotten it together to be a real industry with real codes and standards and protocols, and hydrogen can be used really safely. And it's pretty common in our society. As this slide says, 10 million metric tons are produced every year in the US. It's used to refine petroleum, to treat metals, to hydrogenate food. So margarine is hydrogenated oil, not good for you, but that's what it's used for. And most hydrogen today is produced from natural gas with a process called steam methane reforming. And there are 3 big hydrogen plants in the West, and HTA is going to have to get their hydrogen from one of these plants. There's Air Products in Sacramento, Air Liquide in Las Vegas, and Linde in Ontario. These 3 companies are big international air or gas product companies, and they have been around a long time, and they know what they're doing.
What is steam methane reforming?
It's a process that uses methane and heat and catalysts to decompose methane. Methane is the methane molecule is carbon with 4 hydrogens bonded to it, and the product of steam methane reforming is hydrogen, pure hydrogen gas, which needs to be purified, and carbon dioxide. So there is carbon dioxide produced. There is a greenhouse gas implication of producing hydrogen from methane. Did that answer your question, Jane? I guess so.
I'm sorry, do they capture that and do something with it, or
No,
no?
not now.
Yeah,
No.
but they could.
But I'll say later, it's still advantageous to use, even if you use so-called gray hydrogen.
Thank you.
All right. So green hydrogen is, as I said earlier, the goal, and that's why I got to tell you, that's why I'm in this business to begin with, is that what we're aiming for here is a way to get around without contributing to climate change, which without putting greenhouse gases into the atmosphere. And this is a really good way to do that. And it's one of the only ways, battery electric or fuel cell electric. So the goal is to produce hydrogen from renewable energy. And if you get California money to build a station, you have to produce at least 1/3 of the hydrogen as green hydrogen. And today, the way that people do that is they make hydrogen from so-called renewable natural gas. And most of the renewable natural gas comes from either dairy farms or municipal waste dumps, which produce methane. And the state of California is calling that renewable. I have my doubts about that, but so most green hydrogen today is made by steam methane reforming, the same process as gray hydrogen, just made from natural gas that has been obtained from either waste dumps or from dairy farms. Several companies have plans in place to produce hydrogen through solar electrolysis, which is the way we did it at our station in Southern California, and is the way we did it at the Marine Lab when we did the solar hydrogen project. And people are pretty concerned that hydrogen, and for example, HTA will be using gray hydrogen to begin with 1/3 of it having to be green. And Jerome, you may want to step in and talk about that. But eventually, renewably sourced hydrogen will come. What we need to do now is build the buses and get them working as well as possible. And as we build more and more buses, they will get better and better. We need to build the stations and get that technology to be really robust and reliable. And as we build more and more stations, that will happen. That needs to occur first. and then the renewable hydrogen will come. Jerome, you want to say anything about the 33% renewable hydrogen that?
You mean in terms of how it's currently sourced?
No, that you just need to do it at HTA, right?
Yeah, it's a state requirement. Yeah, the state wants to see to 100%, but they recognize that there's limited supply of renewable hydrogen right now. So right now it's capped at 33.
So my
Okay.
question becomes, you are working on proof of concept to prove that this will ultimately not only save money by having hydrogen fueled buses, fuel cell buses, but that it will be less polluting, be overall cheaper, be more reliable, etc., than gasoline and diesel powered.
Yeah, I don't think it's going to be overall cheaper for quite a while. And we just got to, we subsidize the fossil fuel industry dramatically. And we have gotten used to very inexpensive energy. And our energy is going to cost more going forward. That's just a fact of life. But we have to go green. We have to address climate change. And, as E.F. Schumacher said, it's perverse to calculate the cost of survival. So it's not going to be cheaper in the short run, but it is going to be cleaner, and it is going to save the planet. So all those things are good. So why hydrogen for HTA? Well, they have to, is the answer. The California Air Resources Board has this ICT program, Innovative Clean Transit. And what it says is that for small transit agencies, it's even more prescriptive for large transit agencies. A quarter of all their new bus purchases have to be zero emission by 26, and all of them have to be zero emission by 29. And the HTA, I mean, to their credit, they're trying to get a jump on this and do it earlier. As we said earlier, the choice for zero emission is either battery electric or fuel cell electric. HTA they have two now, right, Jerome? Two battery electric buses?
Three.
Mm-hmm. But they can't do the really challenging routes that HTA has. The RTS route from Trinidad to Scotia and back is challenging. It's on the highway for part of it, and driving 60 or 65 miles an hour is not the most efficient. There are hills to go up and down, and the battery electric buses can't do that one. They are especially compromised when you have to use battery power to run the heater and defroster, which around here is fairly frequently. So the battery electric bus just couldn't cut it, but a fuel cell bus can. It refuels quickly. Instead of taking hours to recharge, it refuels in 10 minutes. It has plenty of range for the Trinidad to Scotia run. The fuel cell, as I said earlier, might be 50% efficient, but that means it still generates waste heat, just like your car engine does. And that waste heat can be used for heating and defrosting, just like you do in your car. And I alluded to this earlier, even when you're running on gray hydrogen, fuel cell electric buses reduce the life cycle greenhouse gas emissions by 15 to 33% compared to diesel. And that's based on an ICCT. They're the International Council on Clean Transportation. They're a European organization, and they are really good. Check out their website. They have really good, interesting analyses on their website. Any questions about that? We got a lot more to talk about. So this is the so-called TERSIP program that Jerome, and there's Jerome, myself, and Greg Pratt, the general manager of HTA. We submitted this proposal to TERSIP. They funded it $39 million. The partners were HTA, the Schatz Center, the Center for Transportation and the Environment, that's a nonprofit that we've worked with that does that aids transit agencies in converting to clean transit. New Flyer is the bus company. We had Air Products and Chemicals as the station contractor. Turned out we had to go out to bid, and we're still in that process now, so we don't know who the station contractor will be. And then HCOG also was a project partner. So we started this project for real last July. So we've been a little less than a year working on it so far. And there are 5 things we promised for the 39 million bucks. We're going to get 11 new fuel cell electric buses to replace diesel buses, mainly on the RTS route that I talked about earlier. We're going to build a hydrogen filling station at HTA's Courtyard in Eureka. HTA is going to institute this new service, the Redwood Coast Express, that goes between Eureka and Ukiah. That will be served with a fuel cell bus. We'll get to that in a minute. And that will be a connection through Mendocino Transit and then eventually the SMART train to the Bay Area. So Jerome can talk about this a little bit, but you can get from Eureka to Ukiah on a bus in 4 hours now. It's pretty amazing, right?
3.5.
3.5.
For $2. For $2. Yep. Yeah, and we're looking to put hydrogen buses on this route once we get them, and I think this will be we expect it to be probably the most demanding route in terms of, you know, it's a long distance at highway miles with some, you know, notable grade elevation changes. So it'll be one of the most strenuous that fuel cell bus is put on in the US, I think.
Absolutely.
So it'll be interesting to see when we expect it to perform well, and Peter will talk about work we've been doing with New Flyer to make sure that it has enough fuel and performance to do that. And yeah, that this RCX, which is, we call this route RCX, Redwood Coast Express, and it runs once a day right now, and we're getting somewhere between 1 and 6 passengers each direction per day. But we expect that to grow. We're in the next month and a half, we're going to formally advertise and announce and promote this new run. And then on top of that, we just received news that Greyhound will discontinue service north of San Francisco starting July 1st. And so we expect that this run will probably help backfill some of that demand. And here we connect with Mendocino, which Mendocino Transit, so that transfer can take you down into Santa Rosa, and then they transfer onto the SMART train in Santa Rosa, and that can take you down to the Bay Area. So with a couple transfers, you can get there in actually about the same amount of time that it took to get there on Greyhound, for quite a bit cheaper. So yeah, it's pretty cool.
It is cool.
Is
Peter,
there a
are there-
relationship between the discontinuation of Greyhound and the startup of this bus?
No,
So
it's
they were stopping anyway because it wasn't economical, it wasn't profitable.
that's right.
Peter,
hadn't been in effect that long.
are there many of these hydrogen fuel cell buses operating in other parts of the world or the United States, or is this going to be a unique experiment here?
Well, the answer is both. There are a lot. I'll get to that, Lou. So stay tuned. But it will be the longest regular route that a fuel cell bus has in America, and maybe in the world. I'm not sure, tell you the truth. But yeah, stay tuned. We're going to talk about that. And the last bullet, we're going to design and build a transit center in downtown Eureka. It's going to be transformative for downtown Eureka to have this new transit center at 3rd and H Streets. It's a parking lot now. Fortunately, the city has a parking lot there that they can turn into a transit center.
Is that subject to litigation that's been going on?
I think not. I think the litigation is other areas. But I'm not certain.
Just curious. You have a question from Leslie Anderson. With more hydrogen cars, would we be using too much fresh water? What about the drought? Can hydrogen be
no.
produced from seawater?
No, the amount of water, it takes 2 gallons of water to make 1 kilogram of hydrogen, which is equivalent to about a gallon of gasoline. So very little water is involved.
And for perspective, it's, somewhere it's like a few 100,000 gallons per day would be needed if we replaced all of the cars in Humboldt County with hydrogen fuel cell cars. And for comparison, the pulp mill, I think, pulled about 3.5 million gallons per day. So if we produced all of the hydrogen needed to replace all the cars in Humboldt County, it'd be a few 100,000 gallons per day.
Yeah. Water is not the issue. There are other, power is the issue, not water. So we did a lot of work to prepare for this grant proposal. One of the things we did was tested a new flyer bus to see if they were the ones that were gonna, they were the company we were gonna write into the proposal. And we actually tested other buses as well, but New Flyer won. And this bus that you see a picture of, this was the actual test run, is an AC Transit bus. It's 3 years old. It was 3 years old when we did this. And it was loaned to us. And New Flyer, as to encourage us, trailered it up here, fueled, because we had no way to fuel it. So it was fully fueled. And we ran it through the RTS route from Trinidad to Scotia and back. And we stopped at all the stops and we kept the schedule the way it is. And one of the stops is at CR. So there's a picture of the bus stopped at CR. The bus did great. It used just a little less than half a tank of fuel to do this back and forth run. That said, based on the test, it was not good enough to make it to Ukiah and back, because that's what it needs to do, because there's no fueling in Ukiah yet. Probably someday there will be. So we negotiated with New Flyer, and they were open to engineering a new generation bus. Of course, now that they have engineered this bus, they are touting it as the greatest thing, and they want to sell a lot of them. So they certainly had their own interest in mind, but they came through for us. They put in a bigger fuel cell, a more powerful fuel cell, 100 versus 85 kilowatts. They put in a bigger motor, 250 versus 210 kilowatts, a bigger battery, 135 versus 100 kilowatt hours, and more hydrogen storage. And that was really the key was more hydrogen storage. So considerable increase from 37 to 56 kilograms. And the target range now is 375 miles. It needs to go about 320 miles to get to Ukiah and back. And we are now under contract. Well, HDA is now under contract with New Flyer. And some of my colleagues and HDA people went to New Flyer's plant for a pre-production meeting to spec out the bus and look at their production facility. We're supposed to get one bus at the end of this year, and that will be the bus that we test to validate that it meets the performance targets that they are providing us with. And then the remaining 10 buses are to be delivered the year after that, the year after next, which is 26.
When
So,
you said one trip per day, were you talking about a round trip per day?
yes. Yes, it's a round trip per day. And I mean, the goal is to have more than one eventually, have better service than that.
Because if you wanted to go and shop in Ukiah versus continue on from there, you'd want to be able to come back with some time in between.
Yes, exactly.
Yeah, right now it's really set up for people that are intending to either continue on south or to stay overnight in Ukiah.
Okay. That
And
makes sense.
yeah, in the future, we increase frequency if we have to get the funding for it. If the state will fund it, essentially, then we can put more service on.
That should be good for Ukiah business.
Yeah,
Are
Peg
they
House,
happy about it?
the Peg House loves us.
Nice to be loved.
So the hydrogen station, that is going to be the first station north of Sacramento in California. And as I said, this is really rewarding for us well, for me personally, I'll speak personally, that we did all this other work and now we're finally getting a hydrogen station here locally. It's going in HDA's courtyard. It'll provide 350 bar, so the 5,000 PSI H35 fueling for the buses. We are also making ready, so providing the piping and the underground conduits and such things for H70 fueling for medium and heavy duty vehicles. And that would be something like the cutaway buses. That a cutaway bus is a smaller bus, like a 16, 20, 24 passenger bus. HTA runs some of those. Or box trucks like FedEx or UPS trucks. And we also have a provision in our RFP for so-called over-the-fence fueling for light-duty vehicles. That is cars mostly. And HDA would get hydrogen cars, and Caltrans is interested in getting hydrogen cars. We have gone out with a request for qualifications, and we've qualified 4 vendors to bid on the station. Right now that is in process, but it's still happening, and we have not yet negotiated a contract with a station developer. And we're hoping that the plan is that the station will be commissioned in the fall of 26. And that's when all the 11 buses should be here at that point. By the way, in the meantime, we will have temporary fueling to fuel the bus that we're testing that is scheduled to come at the end of the year. So this is the kind of station that we are specifying for HTA. It's a liquid hydrogen station. And so the gas company, Air Products, Linde, Air Liquide, one of those, will produce the hydrogen at their plant. And the plants look like, I mean, it looks like an oil refinery. It's got lots of tanks and pipes and such. And they liquefy the hydrogen. Liquid hydrogen is very cold, 20 degrees above absolute zero. And it's transported in an insulated tanker truck, just like you see other fuel being transported. It comes 4,000 kilograms at a time, which is about 18,000 gallons. Liquid hydrogen is not very dense. And that is about, even when we're running fully with all the buses, that's about 2 weeks worth of fuel. So the idea is that we have enough fuel, hopefully, to get through most of the disruptions that we have up here, like the highways closing. That happens in the winter, as everyone knows, and we are planning for that by having a relatively big tank. And the way this works is there's a liquid hydrogen compressor that compresses the hydrogen to the pressure that we need. Then it's vaporized and stored in a gas tank, in a gaseous phase, and then it's delivered to the buses and whatever other vehicles we're fueling. So that's our plans. That's for example, AC Transit has been doing this in a similar way for about 10 years now, and very successfully. I don't know how many of you have seen the fuel cell buses. AC Transit has 13 fuel cell buses on the road right now. And they're pretty frequent in the Bay Area. If you go down to the East Bay, Berkeley, Oakland, it's a good chance you'll see a fuel cell bus. They've been.
Who is AC Transit?
Say that again.
Who is AC Transit and where are
They're
they
the
located?
Transit Authority, transit agency for the East Bay. So Berkeley, Oakland,
For the Alameda and
Angeles.
Contra Costa counties. So
Yeah.
AC is Alameda and Contra Costa.
there you go.
Oh, okay.
Thanks, Jerome.
Okay. And were they funded like we're being funded?
They had various grants, yeah. I mean, this new technology is not cheap. You know, it's like anything else. It needs government assistance to get off the ground. And then once it's off the ground, it'll be self-supporting. And as I said, you know, we're used to a subsidized fossil fuel economy where fuel is pretty darn inexpensive. I mean, even at $5 a gallon or whatever it is, gasoline is a bargain. And that's one of the reasons we haven't changed. We'll have safety oversight by, I won't spend a long time here. There is a hydrogen safety panel at the Pacific Northwest National Labs, and we will use their experience to make sure we have a safe design for our hydrogen fueling station. And this is an architect's conception of what the Earth Center will look like. You are looking, that's H Street in the foreground, and you are looking, let's see.
Northwest.
Northwest, thank you. Yeah, in this conceptual drawing. So the negotiations for this project are ongoing right now. It'll be a multi-story building. It's not clear if it'll be 3 or 4 stories. The bottom floor will be the transit center and other retail businesses. And the upper floors will be apartments, and they will include low and very low income affordable housing. So it'll be wonderful to have this center in downtown Eureka. The city will really profit by having this. HTA and the city of Eureka are both involved in this design build effort.
Just out of curiosity, why are they limiting it to 4 stories?
I don't think they are. I think it's what they can, the developer's budget would allow. I think they're allowed to build up to 7 stories in this particular zone, but I'm not positive on that.
When you say a developer's budget, what does that mean?
Means that they have to include low and very low income affordable housing, and so they can only finance so much.
In other words, it's not economically feasible to make it up to 7 stories.
That's my current understanding. Yeah, but the final number of stories hasn't been finalized.
Interesting. Okay. Thank you. Just curious.
I think you get into differences in prevailing wage once you go above a certain number of stories. I don't remember exactly how many it is in terms of just state law around prevailing wage construction contracts, and so that kind of changes the finances when you get to a certain size.
And here are a couple of slides. I'm almost done. A couple of slides about what's going on worldwide. Somebody, I think, Lou, you asked this question. Somebody asked this question, how many fuel cell buses are there? The answer is a lot. There are over 5,000 in the world, and most of them are in China. 93% of the total are in China. There are 212 in the United States. And there are over 1,000 hydrogen fueling stations. 2/3 are in China, Japan, and Korea. And California right now has 54 stations, and we are by far the leading state in the union when it comes to hydrogen stations. So you see that compared to what's going on worldwide, we are really in our infancy when it comes to fuel cell buses. And
with the current state hydrogen hubs project, it's a project funded by the Federal Department of Energy to kickstart a hydrogen economy, or to further kickstart a hydrogen economy. There are about 1,000 fuel cell buses planned for purchase as part of that project by 2030. And then I think currently there's over 200 fuel cell buses on order by California transit agencies. So we're looking to double that number here pretty quickly.
yeah.
Just out of curiosity, what took us so long?
This is America.
Owned and run by the oil company.
The fossil fuel industry.
Yeah.
Yeah.
Yeah, but if the base is gray hydrogen, that's the fossil fuel industry.
Yeah, but Exxon and Chevron and those guys, they're not involved in making hydrogen. It's the gas companies that are making hydrogen. It's Air Products, Air Liquide, Linde. They're making the hydrogen, not the oil companies. They are using natural gas to do it, but that's a small fraction of the fossil fuel sold.
Yeah, and the goal is for it to be produced renewably.
Yeah.
So, for example, Air Products is developing a massive solar site in Saudi Arabia, I believe. It's basically a huge liquid hydrogen production site that would all be produced with solar. and it would be a major distribution point for their customers globally. And they would ship it, I believe, as ammonia. So, ammonia is very stable in terms of you don't have to, I shouldn't say stable, but you don't have to keep it cryogenically cold. So they would ship it as ammonia and then pull the
Convert it.
hydrogen. Yeah.
Yeah.
Yeah, you're stealing my thunder there.
Sorry about that.
Um,
Slightly tangential, but I think to that question as well, I just ran across this interesting article on how the Chinese electric vehicle market is completely destroying the US automakers. It's an interesting article to see how far the US is lagging behind in development of electric vehicles. So I suspect there's some relationship there.
That's why we're proposing all those tariffs.
yeah,
Exactly. Instead of advancing, they just want to keep
We're
holding on
protecting.
to yeah, exactly.
let's not advance, let's protect.
Well, how about advance and protect?
Yeah, well. Anyway, you see the story with fuel cell buses. I mean, China's way ahead of us. That said, fuel cell buses, as Jerome said, are growing in America, which is good. And there are companies planning to build green hydrogen production plants in the US. So that's good. And here's some other developments worldwide. There are a number of companies, Daimler, Hyundai, Kenworth. So Kenworth and Nikola are both American companies, I believe. I think so. They're all working to produce fuel cell electric long-haul trucks. And as I said earlier, excuse me, for long-haul vehicles, fuel cell electric makes sense, because to get the range you need and the power you need, battery electric just doesn't cut it with this much load. And this recently, Daimler had a long-haul truck. They loaded it fully with 80,000 pounds, and it went 1,000 kilometers, 620 miles on a single tank of liquid hydrogen. And frankly, I think that's the future, is buses, trucks will have not gaseous hydrogen, they'll have liquid hydrogen on board and have a huge range. Hyundai is producing 47, or has already delivered 47 long-haul trucks. They have gaseous storage at 700 bar, and they have a range of 450 miles. And as Jerome said, the state of California is one of the funded hydrogen hubs as part of this big DOE project. It is part of the Infrastructure and Investment Jobs Act. And it's called ARCHES. Isn't that very cute? The Alliance for Renewable Clean Hydrogen Energy Systems. And they got $1.25 billion, a lot of money. And the match totals make it an $11 billion project. And as Jerome said, they want to deploy over 1,000 fuel cell electric buses in California by the end of the decade. And they're saying, I mean, Jerome and I were laughing about this earlier, they're saying that they're going to reduce the cost of clean hydrogen to $2 a kilogram. Yeah. I don't know if they'll make it, but the fact is that they're working hard to get the cost down. And right now, that is an issue. I can tell you that Jerome and I are worried about the cost of hydrogen that we will be producing, to the cost to HTA at our hydrogen station. We're worried that it will be high and we don't know how we're going to pay for it, but it's a lot higher than $2 a kilogram. Even if it made it down to $8 a kilogram, that would be affordable because of the extra efficiency of a fuel cell electric vehicle over a diesel vehicle. And that is the end of our presentation. And thank you for listening.
Well, thank you for presenting. I do have one question. Are you looking at applications for shipping? Which is a big polluting problem.
We aren't, but yes, the world is. And yes, shipping is a big polluting problem. I mean, our whole transit system has developed based on fossil fuels, and it's a huge system. It uses a huge amount of fossil fuels, and it's going to take a long time to change from fossil fuels to renewable fuels. We're on the way, though.
Related to that, I think the Humboldt Harbor District and the port development there, they're definitely looking at doing a fully electrified port, a zero-emission port, and part of that solution would probably be hydrogen. And then also I don't know if it's deployed yet, but there will be the first hydrogen-powered ferry in the country, if not the world, that will soon-ish, I don't know exactly when, but will be operating in San Francisco Bay, doing that service from San Rafael down to San Francisco.
And do you have an anticipated time frame for when the transportation center will be in place and operating?
Right now, I don't. I'm hoping that the first Eureka City Council meeting in June will give more light to that in terms of an anticipated developer schedule. But right now, I don't.
Is there a developer already selected?
Not yet. No.
They got a long ways to go.
Yeah, I think it'll happen quickly. I think I'm hopeful that we'll have one selected in that June that first June city council meeting.
So they already have proposals.
Yeah.
Oh, okay. I didn't know that.
Yeah.
Okay. Anybody else have questions, comments?
I was wondering if it's more dangerous in a vehicle accident, both as a car or transporting the fuel, than it is currently with the gas.
Well, I would push back and say it's exactly the opposite. That fossil fuels, I mean gasoline, diesel, when there's an accident, the fuel can leak out and catch on fire, and hydrogen is under pressure. If there's an accident and there's a leak, it would go right up into the atmosphere and dissipate, whereas the fuel is going to pool and be there to catch on fire and completely burn up. I mean, an example is that accident a few years ago when a tanker truck overturned on an expressway or a freeway in the Bay Area on an overpass, and pretty much melted the overpass. Remember that accident?
Yeah.
If that were hydrogen, that wouldn't have happened. There might have been, the hydrogen could well have ignited, but it would have been a jet of flame going up. And as soon as the pressure, as soon as all the hydrogen was gone, it would have extinguished. There was an accident, a similar accident, not for a vehicle, at the AC Transit fueling station. How many years ago? 5, 6, 7 years ago, something like that. So a pressure relief valve failed and opened without good reason. It wasn't over pressure, but it opened. And a jet of hydrogen escaped and ignited. And they had a burning jet of hydrogen for a few hours until they were able to turn the valves off and get it under control. And nothing else happened. Nothing was burned. That I gotta say, the fire department and the public safety officials kind of freaked out, and they evacuated like 2 or 3 city blocks. There was a high school across the street that they completely evacuated. There was the Pixar studio across the street that they completely evacuated, but nothing happened. The flame burned out, and there were no injuries whatsoever.
I think everybody remembers the video of the Hindenburg. I think
They
that's the
do,
problem.
and I gotta say, I have been reminded of that about 100 times in this
I'll bet.
hydrogen world. Yeah, I had a city council member from the city of Palm Desert, member back in the old days in the 90s. And I was suggesting that when we built the hydrogen station, we could have students, we could have class tours and have it be an educational kind of exhibit for students. And this guy gets up and says, how can you think of even having young people involved in light of the Hindenburg? Well, it turns out one of my colleagues a long time, because of this, did a lot of research, and it turned out that yes, there was hydrogen on board, and yes, the Hindenburg, crashed and burned and people died. But the main culprit was the coating on the outside of the dirigible. It was made of a material that was essentially rocket fuel. And that's what mainly burned. I mean, the hydrogen burned too, but, the cause was not, it wasn't hydrogen's fault. Let me put it that way. So, to the original questioner, is hydrogen dangerous? Yes, it's a flammable gas and it's dangerous. Is it more dangerous than gasoline? I would say it is not. And I think we will have a safer transport system running on hydrogen than we will running on gasoline and diesel.
I
And
think the issue.
the storage
Okay.
tanks are designed to be to resist explosion too. They will, there's a engineered weak point if it's overpressurized, or a relief valve, but it's also just the way it's engineered. You won't have an exploding hydrogen tank. It will leak like Peter described
Yeah,
if something
and
happens.
You were saying that it's being transported as ammonia, is that correct?
no,
No.
at HTA, they will get a delivery of liquid hydrogen in a tanker truck. It'll be a cryogenic tank that is a tank designed to contain very cold liquid, and it'll be a regular tanker truck, just like the gasoline tankers that we're used to seeing. I mean, every once in a while you see one of them that it's a tanker truck, and instead of gasoline, it says hydrogen.
Or oxygen, or like we get shipments of cryogenic oxygen or nitrogen. It's another gas, just one of many gases.
Yeah.
It would be really nice perhaps if you came back and re-upped us in a year or so when we are closer to.
Sure, we'll
having
be
this
happy
happen.
to. Yeah, maybe we'll invite you to ride in a hydrogen bus.
That'd be fun.
They are
We could
fun.
zoom right in on the bus.
They are fun. They're quiet, they're powerful, they're really a nice bus.
Maybe we can have an OLLI trip to Ukiah.
There you go.
We just don't necessarily need to stay overnight.
Yeah, I just wanted to say a little about what just pick up on what Jerome said. The hydrogen tanks are very strong because they have to be to hold hydrogen at high pressure. They are in contrast to the tank that has gasoline in your car. It's nowadays a plastic tank. It used to be a sheet metal tank. You've got 20 gallons of poisonous, flammable liquid in a plastic tank. And you're driving down the highway at 60 miles an hour. That's dangerous. The hydrogen is in a aluminum bladder, carbon fiber wrapped, very strong tank, much less prone to rupture than the gasoline tank in your car.
Are there any other questions from anybody?
Well, going back to the ammonia question, you did mention something about it being shipped as ammonia, maybe not up to Humboldt County, but
Right.
generally. And ammonia is such nasty stuff. What's the relationship between hydrogen and ammonia, other than when hydrogen is used to make fertilizer?
Yeah, ammonia is, yes, used. Ammonium nitrate is a fertilizer, also an explosive. Ammonia is, the ammonia molecule is nitrogen bonded to 3 hydrogen atoms. So there's a lot of hydrogen stored in ammonia. And yes, it's a caustic, poisonous material, but as Jerome was saying, it's pretty easily handled. I mean, we handle other poisonous materials in our society. It's pretty easily handled. And the good news in terms of transporting hydrogen is taking ammonia and then reacting it with the catalyst to free up the hydrogen. So if you decompose ammonia, you get hydrogen and nitrogen. So nothing toxic at all. And it's very easy to do. It's an easy process to accomplish. So once the ammonia gets here, transforming it to, or transforming it to hydrogen is going to be easy. And, we used to use ammonia pretty commonly in refrigeration systems. It was a refrigerant used. My dad used to work, it was a long time ago, so it's in the 40s. My dad used to work repairing ammonia systems. He said when a troublesome customer would bug him, he would crack the valve a little bit and the guy would disappear.
Very effective deterrent.
Evidently it worked.
I can imagine. Any other questions? If not, thank you so very much, both of you, Peter and Jerome, and we're looking forward to seeing this get realized. And we hope all of you will re-up your membership with OLLI for the coming year. You can do it now, and it will take effect immediately for the whole next year, starting July 1. Actually, it is July 1, isn't it, Erin?
Yes,
Because
it's July 1.
our brown bag lunches start up again on June 17th. So do re-up, because if you're not a member at that time, you may not get an invite. Only members get invitations, but you can always go to the website, by the way. And our first brown bag lunch will be on the Great Redwood Trail and what's happening with that. And we look forward to seeing you all back with our brown bag lunch program and with OLLI classes in the summer session.
Thank you all. Have a lovely rest of your Monday.
Thank you.
Thanks, everyone.
Beautiful.